back. In this chunk, I am going to introduce you to a very useful tool for your professional toolbox. It is a very constructive way to really learn environmental geoscience, and we will be using this method in this course. It is known as concept sketches. The chunk is based on research by Steve Reynolds and Julia Johnson of Arizona State University. Julia gave me permission to use their research and some of their illustrations as I wanted to develop this chunk for you. So as usual, before we jump into our discussion, let me show you the learning objectives for this chunk. Take some time to study the learning objectives before you go to the next slide. The learning objectives. Concept sketches are 1. Simplified sketches. 2. Concisely annotate and label features and 3. Show processes, concepts, and interrelationships. They also use complete sentences to emphasize the processes. And concept sketches help you to see, organize, and explain your knowledge, and can be generated from field observations, photographs, and detailed textbook-style illustrations. They can also be generated while reading your textbook. They help you process information fully, consolidate your understanding, and personalize the information to suit your learning style. And they help you develop critical thinking skills and learn communication skills. Okay, let's learn about concept sketches. As geoscientists, we are all natural sketchers, in our field notebooks, on the blackboard, in our publications and formal presentations, or on napkins. Sketches and other illustrations are an important way we record our observations and thoughts, organize our knowledge, try to visualize geometries of landforms, show sequences of events, illustrate processes that shape the surface of Earth over time, and convey ideas to others. We have all made sketches. Sketching is one way we make our thoughts visible. So, if this is an important way we learn and wrestle with problems, why aren't we exploring the visual world of the environment in the same way? Have you ever thought about this? The textbook for this course contains a lot of detailed and artistically illustrated diagrams, each depicting fundamental environmental geoscience concepts. Unfortunately, I know from teaching courses in the past, that many of my students just read the words and skip through the textbook without really examining or internalizing the figures. They missed a lot. They missed the value of these figures in constructing their own knowledge. And, I assume that many of you have done this with textbooks in other courses. I believe this is not your fault. Whatever the reason, many of you have never been shown how to interpret these scientific illustrations, nor have you been tutored how to identify the important factors represented in each. Thus, in my class you are going to learn an easy way to improve how you interpret or use scientific illustrations through a technique I have learned called concept sketching. In environmental geosciences you are going to learn how to sketch your own versions of the concepts in an active learning environment. The idea of designing ways to help students relate and link otherwise disparate pieces of information is not new. This is known as concept maps, which are flow chart-like or web-like diagrams that attempt to portray the hierarchies and other relationships of related concepts. Concept maps are a useful tool to help articulate ideas, identify and arrange key concepts, and see how these ideas and concepts are connected. For the geosciences, concept maps are not optimal because they fail to take advantage of the very visual nature of our science and do not preserve the spatial relationships of different features, such as an andesitic stratovolcano positioned above a subduction zone. Steve Reynolds and Julia Johnson from my alma mater, Arizona State University, developed the idea of a concept sketch, as a technique to help students identify and link key concepts, but emphasizing the spatial relationships between concepts and simulating the more environmental portrayals, such as cross-sections, profiles, and outcrop maps. Okay, enough background. Let's get on to learning how to construct concept sketches. Let me set the stage by saying that a concept sketch is a simplified sketch illustrating the main aspects of a concept or system, annotated with concise but complete labels. When we talk about concept sketches in geosciences, I want you to understand that ours are very different from the concept sketch term that is used by artists and architects to imply a preliminary portrayal of an idea or future project. So, what is a geoscience concept sketch? A geoscience concept sketch has three important characteristics or goals. These are, identify the features, depict the processes that are occurring, and characterize the relationships between features and processes. The concept sketch on your computer screen is a rotational landslide. Let's take some time to study this sketch. You can see that this sketch illustrates some of the processes occurring like gravity and resistance. The concept sketch also shows the main features that are produced, a rotational landslide block, sag ponds, and unstable slope. And, importantly, it also shows how the processes and features are related. Okay, let's look at another example in the next slide that is closer to environmental geology. The concept sketch on your screen shows a cone of depression that forms because of overpumping of groundwater. As we study this concept sketch, I want you to notice it is a two-panel sketch, which shows two stages of development, before and after overpumping. This concept sketch adds a temporal component to our explanation. As we continue to study this diagram in detail, I want you to notice that the flow direction of groundwater is shown, with one set of arrows, and the lowering of the water table is shown, with another set of arrows. When you use arrows, as in this case, or symbols on other concept sketches, it is essential to clearly indicate what each arrow is trying to show. In this concept sketch, we differentiate between 1. The movement or flow of water, 2. How a feature changes over time as in the lowering of the water table. Arrows can also be very useful in showing the sequence in which a diagram should be read. Remember, I mentioned that one of the aspects of concept sketches was communication skills. If you do not tell the reader the meaning of the arrows, or other symbols, they might incorrectly view, or interpret your concept sketch. Concept sketches can be drawn as two-dimensional or as three-dimensional. Although most concept sketches are simplified cross-sections, it might be more appropriate, in certain situations, to draw concept sketches that are map views, or 3D perspectives. The figure on your computer screen shows 2D and 3D concept sketches of glacial processes. Okay, it is time to construct a concept sketch. I am going to suggest some steps to help you as you learn this process. First, I have had students tell me I cannot do this because I cannot draw. Everyone can draw. These are not artists drawing. They are your sketches. Okay, the first step is to pick a topic or concept you want to master. You will first need background information on the concept, and then construct a concept sketch that portrays the essential aspects. I suggest a diagram in your textbook, or a photograph of an environmental geology concept. The steps are as follows. Pick a topic or concept you want to master. Gather background information. Define the size of your sketch. Place your sketch on the page to allow space around, for annotation. Begin with general statements about the process. Add details to explain spatial and temporal characteristics. You will get the chance to put these steps in use in your company projects. We will also give you some more tips on constructing your concept sketch during company meetings. As you begin, I would suggest that you find a friend or fellow classmate and do this together. To give you an idea of the process, let's use the photograph you see on your screen. This is a photograph I took in Ouray, Colorado. As you study the photograph, write down your observations. What is the photograph showing? What is the rock type? How thick are the layers? What is the orientation of the layers in different parts of the photograph? Is there a pattern to the features? How might this have formed? How would you show the relationship between the rocks and processes? As we observe the photograph, we notice the following. The rocks in the lower part are layered, and appear to stand vertically. The rocks above the vertical rocks are more or less horizontal. There appears to be an uneven surface between the vertical rocks and the horizontal rocks. There is an uneven surface above the white rocks, the horizontal rocks, above the uneven surface, on the top of the lower horizontal layers, appear to be darker in color. A steep canyon, on the left, is cutting through all the rock layers. At this point, we will begin to draw a concept sketch of the photograph. After we complete the sketch, we would describe, to our friend or classmate, how the concept sketch represents the scene. The questions and feedback we receive from the friend or classmate will help us refine our concept sketch by correcting any gaps or misunderstandings made visible by our concept sketch. Okay, your friend was correct. Process was left off. This is very important, as its inclusion illustrates that you really understand how things were formed. And, you notice the crowd is happy, but still asking for more. What needs to be added? In fact, send me an email with your additions to the diagram on slide 17. So, why am I so keen on getting you to use concept sketches? A lot of research on learning shows that construction of a concept sketch results in you interacting with the material in a meaningful way by creating a sketch. The bottom line is, you are engaged in a deeper level of mental processing to decide what is important and what is not. You are mastering the materials. Think about the steps we just went through to construct the concept sketch of the U-ray photograph. We had to view the photograph, then we had to think about relationships between features, and to arrange items in a hierarchy. We then had to portray these relationships on paper. We then showed our diagram to a friend, or classmate, and explained what our concept sketch was showing. By discussing this sketch with our friend, or classmate, we had a chance to sound like an environmental geologist talking. In other words, we were using the words of the profession to talk about geology. And, one of the most important benefits of verbalizing the concept sketch to our friend actually promotes transfer of information from short-term to long-term memory. This knowledge is yours to keep long after you leave my classroom. You are probably thinking, I can use these concept sketches to learn the material. Is that all they are good for? No. Absolutely not. You will find concept sketches to be very useful in completing your company projects. Remember, in an earlier chunk, we talked about the structure of this course and that the chunks provide the theory and background information. And, the company projects provide the opportunities for you to combine the theory and background information with the tools and techniques to solve a problem. The education people call this a transfer process. In your company project, you are going to be asked to do the following. Prediction questions, you will be asked to make predictions for your clients. Troubleshooting questions, you will be asked to provide and make recommendations about how the system might fail or function abnormally, and to make recommendations on how to fix the system, if it did fail. Refinement questions, you will be asked what needs to be done to improve the system. Causal or conceptual questions, you will be asked to explain to your client the underlying processes, and the causes and consequences, so they understand how you arrived at your recommendations for the respective projects. Let's go back to our example of the 2 water wells in the aquifer, and talk about the 4 types of questions we just mentioned in the previous slide. The diagram on your slide is our concept sketch of the aquifer. Let's think about the questions this concept sketch would lead us to ask. To help you with this, I am going to give you 4 questions. The type of question, and a short example question are shown on your slide. The type of questions and the sample questions are: Prediction question. What would happen to the shape of the water table if you turned off the large pump? Troubleshooting question. How could you have prevented the smaller well from drying up? Refinement question. What could you change now to decrease the impact of pumping from the larger well? Causal or conceptual question. What factors influence whether a cone of depression forms from pumping? Okay, now it's your turn. I want you to develop a prediction question, a troubleshooting question, a refinement question, and a causal or conceptual question related to the aquifer and email these to me. I want to end this chunk on concept sketches by suggesting one other, very beneficial use of concept sketches, and, that is, in the field or on a field trip. Using concept sketches on field trips is a terrific alternative, or supplement to traditional field notes. We have all been to the field with our trusty field book. We take field notes, and dutifully draw sketches. In teaching field methods and field camp, I watched a lot of students use their field books as a place to write rock descriptions, and to record orientations of structures and sketches simply, as a record of what they saw. No thinking, just recording. And, unfortunately in the last few years, with cell phones so compact, it is emphasizing the perception that photos are better, and sketches are disappearing from field notes. So, when they return to their field books, at a later date, that photograph, sketchy notes, and strike and dip measurements are of limited use. I challenge you to use concept sketches next time you are in the field. And, this is why. Constructing a concept sketch in the field will lead you to begin to ask, what processes formed what I see? What evidence do I see in the outcrop to support my interpretation? Making concept sketches in the field will increase your observational skills. You will begin to observe more carefully, and make decisions about what is and what isn't important to record in a sketch. Then, when you get back to school to write your report, you will find it rather easy and straightforward. The reason? By constructing that concept sketch in the field, you left that outcrop having committed to a level of understanding of process and outcome that I bet were not in your written notes that you jotted down in the field before. We have now really come to the end of this very important chunk. On your screen are the learning objectives for this chunk. Make sure you understand the objectives for this chunk. You will have company projects that will give you more insight and practice with concept sketches. The learning objectives are:
Concept sketches are 1. Simplified sketches 2. Concisely annotate and label features, and 3. Show processes, concepts, and interrelationships. They also use complete sentences to emphasize the processes. And concept sketches help you to see, organize, and explain your knowledge, and can be generated from field observations, photographs, and detailed textbook-style illustrations. They can also be generated while reading your textbook. They help you process information fully, consolidate your understanding, and personalize the information to suit your learning style. And they help you develop critical thinking skills and learn communication skills.
We have now come to the end of this chunk. And don't forget to email me your questions.